Hi, and welcome to National 5 Trigonometric Identities. Going to have a look at the questions that you were set. So the first question was, show that tan x cos x equals sin x. So trigonometric identities at National 5, there's two things we are told. First thing, that tan x equals sin x divided by cosine x. And also sine squared x plus cosine squared x equals 1. One's just kind of going off the side there, but equals 1. So basically, at the start of the question, I'm going to look for either tan x, which we've got here, or sin x over cos x. And I'm just going to replace one with the other. Or if there's sine squared plus cos squared in there somewhere, or if there's a 1, I'm going to replace the sine squared plus cos squared with a 1, or the 1 with sine squared plus cos squared. So we'll go through them. So the first one here, tan x cos x, we need to show that that equals sin x. So what I'm going to do here, I'm going to replace my tan x with sin x over cos x. So I have sin x over cos x multiplied by cos x. So I'm multiplying a fraction by cos x here. So if we want to, we can think of cos x as cos x divided by 1. So then it's multiplying fractions together, top times top, bottom times bottom, or numerator multiplied by numerator, all over denominator multiplied by denominator. So we'll get sin x cos x for the numerator, cos x times 1 for the denominator, that's just cos x or cosine x. And then anything divided by itself is 1. So here, cosine x divided by cosine x would just be 1 over 1, which leaves the sin x there. So sin x multiplied by 1 is just sin x. Okay, so what have we done there? We've spotted the tan x, we've replaced it with sin over cos, done a bit of fraction work, and out pops the answer. Okay, let's have a look at question 2. Just zoom in a little bit here. So we need to show that sin x over tan x equals cosine x. So again, there's that tan x. I'm going to replace that with sin x over cos x. So on the second line here, we have sin x divided by all of sin x over cos x. Next thing we're going to do here, well, we're dividing by a fraction. So we flip the fraction upside down, we invert the fraction and multiply by that. So sin x over 1 multiplied by cos x over sin x. So again, what we're doing here, if we're using correct mathematical language, and multiplying by the reciprocal, which is basically what we get when we flip a fraction upside down. So sin x multiplied by cos x, all over 1 multiplied by sin x. And here, sin x divided by sin x is just 1, which leaves us with a cosine of x, which is what we're asked to show in the question. Let's have a look at number 3. Similar idea, show tan x over sin x equals 1 over the cosine of x. So again, substitute in sin x over cos x. So here we've got sin x over cos x divided by sin x. So if we've got this fraction and we're dividing that by another term, that term just comes on at the bottom. It's just like if we're doing a half divided by 2, that'd be 1 over 2 times 2, which is a quarter. Or if we're doing 1/3 divided by 5, that would become 1 over 3 times 5, which is a 15th. So if you think about it, if you have a third and you divide that into 5 smaller pieces, you will get 15ths. Okay, so that's why that works. So basically this bottom term and the sin x on the bottom basically come together on the denominator. So I've got sin x over sin x times cos x. So remember here, sin x divided by sin x is just 1. So we're going to get a 1 on the top for the numerator, so 1 divided by cos x. Okay, right, I'll do 4, 5 and 6 in a separate video.